Okay guys, this is part 3 of the video of what is Kaspa and how it works, so let's get into the video. So, where we left off is we were talking about how does Kaspa use proof of work and what is the GoStag/Phantom protocol. So let's go over GoStag/Phantom protocol first, and then we can go over how Kaspa uses proof of work. So, Kaspa uses the GoStag/Phantom protocol, which is something that it created and invented. GoStag/Phantom protocol, it is two interconnected concepts that form the core of Kaspa's blockchain technology. They work together to provide decentralization, security, and scalability on Kaspa's network. GoStag has a couple of components, and I'm going to be going over the definitions. So the first component is greedy heaviest chain subtree, and what this means is that a consensus algorithm that determines the valid chain of blocks in a blockchain. It's a variant of the Ghost protocol, which is designed to handle chains with forks, and I'll be going over what a fork is in a second. The next component is a longest chain rule. This is GoStag follows the longest chain rule, meaning that the chain with the most cumulative work done is considered the valid chain. The next component is subtrees. GoStag divides the blockchain into subtrees, allowing it to process transactions more efficiently and prevent orphan blocks. So let's explain this simply. Imagine a line of blocks, okay guys? So each block is in this little chain that goes horizontally, and basically each block is just information or transaction information, stuff like that. This line represents the blockchain right here. Each block contains a record of transactions. Now imagine that the line splits into two branches, kind of like a fork, with this illustration right here. Not sure if you guys can see it, but I'm gonna draw a couple more arrows. So now it splits into a fork, and then let's say we add one extra block to this blockchain right here instead of this one. This one would be considered the valid chain because it has more work done on the chain. Thus, then it's confirmed as the valid one. So, okay, now imagine that the line splits into two branches. This is called a fork. Forks can happen in blockchains due to network delays or disagreements between miners. GoStag is a way to decide which branch is the correct one. It looks at the total amount of work that has been done on each branch. The branch with the most work is considered the main chain. GoStag helps the blockchain stay consistent and avoid confusion. It ensures everyone agrees on which transactions are valid and which ones are not. So that's what GoStag is. So now let's go into how does Kaspa use proof of work. So the first thing is transaction pool. Transactions are collected into a pool. Number 2, block creation. Miners create new blocks containing transactions in a nonce. A nonce is basically a random number. 3 is hashing. The miner calculates a hash of a block, which is a unique digital fingerprint. 4 is puzzle solving. The miner tries to find a hash that meets a specific criteria, such as starting with a certain number of zeros. So now let's flip the board over and continue with how Kaspa uses proof of work. 5 is validation. Once a miner finds a valid hash, the block is validated by other nodes in the network. 6, reward. The miner who creates the valid block is rewarded with newly minted Kaspa coins. And that's how Kaspa uses proof of work. And part number 4, I'll be going over what a hash is, what a node is, the Phantom protocol, which is the second part of the GoStag Phantom protocol, which basically Kaspa is built upon and how it basically functions. And then after that, I'll go over the DAG, which is directed acyclic graph, and then the trilemma and how Kaspa solves the trilemma.